If we have a set of numbers x1, x2, x3, so on up to xn, so that's n numbers, and x bar is the mean or average of these numbers, then the standard deviation is given by this formula. So S is the square root of x1 minus x bar the whole squared plus x2 minus x bar the whole squared plus x3 minus x bar the whole squared plus, and we keep going until we hit the last number, which is xn minus x bar the whole squared. We add all these numbers and divide by n minus 1 to get the standard deviation. So the standard deviation is a measure of how far a number in the data set is from the mean on an average. So it measures the spread of the data. How far are these numbers from the central number, which is x bar? So that's what standard deviation measures. Now let's look at certain data sets. Let's look at the first column, which is the length in centimeters. Now the second column is the exact same numbers as in the first column, except that they're measured in meters rather than centimeters. So 995 centimeters is the same as 9.95 meters. So they are the same numbers, but the units of measurement are different. So let's see if the units of measurement makes a difference in the measurement of, or in the calculation of, standard deviation. So let's calculate standard deviation. Go to statistics, descriptive statistics, the length in centimeters, the same lengths converted to meters, and calculate. Now I want you to look at the column which says standard deviation. The standard deviation of the lengths measured in centimeters is 188.3, and the standard deviation of the lengths measured in meters is 1.883. So there is a difference in the value of standard deviation if the units of measurement are different. So the standard deviation in the first case, which is when the length is given in centimeters, would be 188.3 centimeters. So the units of measurement of standard deviation is exactly the same as the unit of measurement of the actual data values. If the length is given in meters, then the standard deviation is 1.883 meters. So the unit of measurement of standard deviation is the same as the unit of measurement of the numbers in the data set. Now let's look at the column headed by x. So we're looking at the column x. So the variable is x. We have -2, -1, 0, 1, and 2. So we don't have to use our calculators to say that the average or the mean of these numbers is 0. When we add all these numbers, we get a 0. So the mean is the sum of all numbers divided by the total number of numbers. If the sum of all numbers is 0, then the average is 0. Now, the column y is the same as column x, except that we have removed 0. Now let's see if that would make a difference in the measurement of standard deviation. So let's go back to statistics, descriptive statistics. Let's select x and y and see if there's a difference in the standard deviation. So look at the standard deviation of x, it's 1.581. Y is the same numbers as in x, except that 0 is discarded, and the standard deviation does change to 1.826. So the two standard deviations are different when I discard 0, which is the average of the set x. Now look at that last column. All the numbers are the same. Now remember that standard deviation is a measure of spread, and here there is no spread. All numbers are the same. So if there is no spread, we can say that the standard deviation is equal to 0. Let's just go back and see if we can figure this out by using the formula. So the numbers are 6, 6, 6, 6, 6. So there are 5 numbers, let's say. Each number is a 6. So if we find the standard deviation, it'll be the square root of, and remember that the average of all these numbers, so add all the numbers, divide by the total number of numbers, so that'll be 6 times 1, 2, 3, 4, 5. So that's the total when you add all the numbers, divided by the total number of numbers, which is 5. So x bar equals 6. So notice that if we plug that into the formula, it would be first number 6 minus x bar, which is 6 the whole squared, plus second number 6 minus x bar 6 the whole squared. So notice that each of these numbers is a 6 minus 6 the whole squared, and divide by 5 minus 1. So that would really be a 0 over 4, which is equal to a 0. So if all the numbers are the same, then the standard deviation would have to be 0. One last thing, the standard deviation, the way it is defined is that it is the positive square root of the sum of the squares inside the radical sign. You see that this is the sum of the squares. So by definition, standard deviation is a positive number. It cannot be negative by definition. And I think we've already discussed units. The unit, if the unit of measurement of the variable is centimeters, then the standard deviation is in centimeters. If the unit of measurement is in feet, then standard deviation is also in feet. It has the same unit as the measurement, which is the variable.